This is Skills Practice 54, Second Law, question number 1. So number 1 asks us to predict whether the delta S is positive or negative for the reactions that it gives us. So the first reaction is right there. And basically, since the reaction goes from a gas and a solid to just a solid, it becomes less entropic because it gets rid of all the microstates available to the gas, since gas is the state of matter with the most microstates available to it. Part B, that's the reaction. And you need to know that gas particles are free to move around more, so there's more possibilities for positions of the gas particles at a given time, meaning there's more microstates available. And since the reaction goes from a solid and a gas to just a gas, it's creating more microstates because gas has more microstates available to it, like we just said. So this reaction has a positive entropy change, delta S, because it goes from less microstates to more microstates. There's the reaction for part C. So since the reaction goes from a liquid and a gas to a liquid and a gas, we can't establish the entropy change based on just the states of matter. But we do know that this reaction goes from 5 moles of reactant to 4 moles of product, and the moles of gas are reduced by 1. So this reaction has a negative delta S because it goes from more microstates, more moles, to less microstates, and it's keeping the same amount of liquid and losing a mole of gas, which reduces the number of microstates because gas has the most microstates available to it of all the states of matter, like we said before. So if you're taking out the reactant with, or the substance with the most microstates, then you're obviously decreasing the entropy, if that makes sense. This is the reaction for part D. So gases have more microstates available to them than solids do, like we said before. Solids have the least possible amount of microstates compared to the other two states of matter. Since the reactant goes from gas to solid, it's losing microstates, and this reaction then has a negative delta S, a negative entropy change, because it goes from more microstates to less microstates. Question number 2 asks us to calculate the entropy change for the given reactions using standard entropy values, which are values that you have to look up, or SwissTech will give them to you or something. So that's the first reaction, and you have to use Hess's law, which states that change in entropy of reaction is equal to the sum of the standard entropies of the products, and you have to multiply the standard entropies by the coefficients in the equation, the number of moles, because the standard molar entropy, that's for 1 mole, minus the sum of the standard entropies of the reactants, again multiplied by the coefficients of the balanced equation. So it's products minus reactants. So those are the given values for the substances, and then you do products minus reactants. So you add the sum of the products multiplied by the coefficients. So you have 2 times the standard molar entropy value for SO2 plus the standard molar entropy value of O2 minus 2 times the standard molar entropy value of SO3. And make sure you get them in the right states of matter, because the values are different depending on the states of matter. So then you go on to the next equation, you do the same thing, you look up the values, you do sum of the products minus sum of the reactants. Don't forget to make sure you have the right states of matter. Same for part C, look them up, products minus reactants. And the reason it's in joules and not joules per moles Kelvin, the moles Kelvin is just like at standard temperature and per 1 mole. So you don't really count that in the equation. The last question, what does it mean for reaction to be spontaneous? If someone is spontaneous, it means they make on-the-spot decisions without any influence of anyone else. So spontaneous reaction occurs with no outside influence, meaning no catalyst and stuff like that. So that's basically it.